Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at equations with pronumerals on both sides. Remember, pronumeral is just a letter. So we're going to have equations that look like this. 3x equals, say, 2x plus 8. So by both sides, I mean both sides of the equal sign. So follow these 3 steps. Expand any brackets if there are any. Then we use the principle from the previous lesson. If x is in more than one spot, we need to first get it to one spot. So the way you do that, if it's on both sides of the equal sign, is to subtract the pronumeral letter with the lowest coefficient. Remember, what you do to one side of the equation, you have to do to the other. And then it'll become just a normal equation. So in this equation in blue, the x, the pronumeral with the lowest coefficient, is this one here. Coefficient means number in front of. So this has a 2 in front of it. This x has a 3 in front of it. So we're going to subtract 2x from both sides of the equation. So 3x minus 2x is x. 2x minus 2x, the reason we're doing it, they cancel out. I'm just left with x equals 8. That is the solution. You probably wish all of them were that simple, but that is not always the case. Let's look at another one. 7x plus 12 equals 3x minus 4. We're going to do it the same way. There's no brackets to expand. So we find the pronumeral with the lowest coefficient. In that case, that's this one. And we subtract from both sides. So we're going to subtract 3x from both sides. So 7x minus 3x is 4x. We haven't done anything to the 12. It stays as it is. 3x minus 3x is 0. They cancel out. I'm left with 4x plus 12 is minus 4. We're just going to solve this as normal. So what we need to do is subtract 12 from both sides. So we get 4x equals negative 16. Then we need to divide each side by 4 to undo timesing by 4. So x is just minus 16 divided by 4, which is negative 4. So if I were to substitute negative 4 here and here, I'd get a true statement. The left-hand side is 7 times minus 4 plus 12, which is negative 16. The right-hand side is 3 times negative 4 minus 4, which is negative 16. That's a true statement. 7 times negative 4 plus 12 does equal 3 times negative 4 minus 4. So if I substitute x into the original equation, if I substitute x is minus 4, I get a true statement. Therefore, that's the solution. So let's look at another example. So let's try this equation here. Minus x plus 5 equals 4x minus 3. So we're not going to do this any differently. There are no brackets to expand. We're going to subtract the x with the lowest coefficient. So this x has a coefficient of minus 1. If it's not written in front of the x, it's a 1. And there's a minus as well. This x here has a coefficient of 4. Minus 1 is lower than 4. So what I'm going to do is subtract minus x or minus 1x from both sides. But you remember, subtracting subtracting a minus x means adding x. 2 negatives make a positive. So I'm actually adding x to both sides of this equation. So minus x plus x cancels out. I'm left with 5 equals 4x plus x minus 3. Then I add 3 to both sides and I divide by 5. So this time the answer is x equals 1.6. Your answer does not have to be a whole number. Again, this is the solution because if I substitute x is 1.6 here and here, I get a true statement. Let's look at some examples now with brackets. So let's have a look at this equation. Again, we have x on both sides of the equation. Step 1 on the previous slide was to expand brackets if necessary. So that's what we're going to do. So remember, we distribute the thing outside the brackets to everything inside the brackets. 6 times x, 6 times not 5, but negative 5 equals negative 30. This is not a 9, this is a minus 9. Minus 9 times positive 3, minus 9 times minus x. Now, this equation looks like the ones we were just doing. Clearly, this one here, the 6x, has the lowest, is the x with the lowest coefficient. So we're going to subtract 6x from both sides of the equation. So we're left with minus 30 equals minus 27. 9x minus 6x is 3x. So how do we solve this equation? Well, this one here is a minus 27, so we're going to undo that by adding 27 to both sides. So I get minus 30 plus 27, which is minus 3 equals 3x. Now I want to undo timesing by 3 by dividing by 3. So x is minus 3 divided by 3 minus 1. If I substitute minus 1 here and here, you'll see that both sides of the equation equal negative 36. So I have a true statement. All right, this has been the luckiest maths teacher in the world. Have a great day.